I've been doing a lot of these hack yourself first workshops lately where I go into an organization, spend a couple of days, and we go through and we find all of these common security risks and teach developers how to exploit them and then how to fix them, which is good because exploiting them is fun, but fixing them is kind of important, particularly when you're in there in a large corporate trying to protect their things. Anyway, one of the things that I've been doing a lot of is content security policies, or CSP. And I thought what I'd do is just do this very sort of ad hoc video without any editing, showing you what I do in the workshops, what the CSP is there to help prevent, and a kind of entertaining way of actually seeing how it works. And here's where I want to start. I saw this talk last year at AppSec EU in Amsterdam by this guy, Breno de Winter. He's the guy who's done this video. And what Breno thought he'd do is go around and find XSS flaws in banks. And he made this video. Just have a look at the video, and then I'll start talking about CSPs. Now keep in mind that everything you're seeing here is happening by cross-site scripting. So all of this could be reflected cross-site scripting. You see some of the URLs, it's just a link. Someone follows the link, and they get this. Which is kind of awesome, right? I mean, kind of awesome, at least in the way that, hey, isn't it cool? Someone is getting the bank to dance around. Now, attackers generally don't just get victims' browsers to do the Harlem Shake, as annoying as that is. They're going to be looking to do things like load in external JavaScript files, which can then steal cookies, or perhaps embed an image on the page. And when the source of the image is set, then it also embeds other private information that then gets sent off to the other site. However, this is kind of fun. This is kind of entertaining, getting sites to do the Harlem Shake. So here's what I want to show you. There is a little script just here. I didn't create it, someone else wrote it. There's a link to the source there on line 1. Take a note of that because you're going to want to do this. You're going to want to go and find sites and get them to do exactly what we're about to do. So here's what I'm going to do. I'm just going to copy everything in that window onto my clipboard. And then I'm going to jump back into the browser and I'm going to go to this sort of site that you kind of don't want to have security vulnerabilities. Somewhere like, let's say, how about Bank of America? Let's give those guys a go. Now, here's what we're going to do. We're going to load up the Bank of America website. All of this is just sort of ad hoc, on the fly. This is exactly how it happens. Into the DevTools, onto the console tab, type in that script or paste in that script, enter. And the site is dancing. Isn't that easy? It's kind of cool too, because even like the nav and the flyouts will dance as you browse around them. So this is actually running external arbitrary script in the browser. Now, when I do this in the workshops, and I've done this in a few of my talks as well, I show this and then I say to people, well, is this a security risk? And everybody wants to say no, because it's just happening in your browser. They want to say no, but they know that this is going somewhere. So they kind of sit there in stunned silence. But this is the normal assumption people will make. It's not a security risk because you're basically just modifying something on the client side. It's kind of like saying, if I opened my DevTools and I went and inspected an element and I found somewhere, let's find somewhere some text, maybe contact us up here. And I changed it, and instead of being contact us, we wanted to make it, let's see, contact them. Is this a security risk? We've just changed the contents of the page, but it's only on my browser, on my local machine, so no, it's not. But let me go and show you something different, and this may then help put in context what I mean by whether or not this is a security risk. So we'll go here. We'll go off to my Have I Been Pwned site. And this is a site I've spent a lot of time trying to secure. All right, so just to show you what the site actually is here, there we go, whole site is there. Just a normal site insofar as it loads our HTTPS in the browser. Let's go and make it shake. So F12, DevTools, back to the console, paste the script, run, and it doesn't shake. No shaking at all. In fact, not only does it not shake, but we've got a number of errors here in the console. And I want to look particularly closely at the first two errors. Have a look at this. First one says, refused to load the style sheet. And then we've got this S3 Amazon AWS URL, and inevitably at the end down here in the path, we've got a .css file. Second one, refused to load media, also from s3.amazon AWS, and we've got an MP3 file there. Now with both of these, you'll see it then says, because it violates the following content security policy directive. And then it goes on about media source and so on and so forth. So what's actually happened here is that this Harlem Shake script works by loading CSS, which does all the transitions and the jumping around, and also by loading an MP3, which is that insanely infuriating music that you hear in the background. So what we're actually trying to do here when we run the script is we're trying to load external resources which this site, Have I Been Pwned, doesn't think should be loaded, and the content security policy is stopping them from being loaded. So let me show you what the content security policy looks like for Have I Been Pwned, how you set it, and then why all of this actually makes sense. If we go over to the Network tab here in the browser, and we reload the page, because I want to see all the requests, and in fact what I really want to see is this first request, and what I especially want to see, and we'll zoom in on this guy a little bit, is the response. So see how we've got a content security policy header here, and then we've got a lot of text afterwards. All right, it's a great big kludge of text, but it is just text. The content security policy is nothing more than a response header. Now here's what we can do. I want to show you how this actually can be read in a more human legible fashion. I'll jump over here and we'll go to report-uri/home/analysis. And report-uri is a free service made by a mate of mine, a bloke called Scott Helm. You may remember Scott from such videos as Here is How to Hack My Nissan from the Other Side of the World. Anyway, moving on. What Report URI can do is you enter the domain, so we'll take, say, haveibeenpwned.com, and it's going to go off and not do anything because it's probably hit the HTTP address. So let's just hit HTTPS, so then it will redirect, or rather not redirect, it will go and actually get the page which has the content security policy header. And now we've got a nice sort of human readable response. And all of this is, everything you see here is just this great big kludge of text. It's just rendered in a really nice human readable fashion. So let's talk about what we're seeing here on the screen. I'll explain this, and I'm going to do it in a couple of iterations. So the first thing we're seeing here is we've got all of these sources, default sources. Default allows sources for, and then we've got things like child source. So a child source is a frame that you put on a page. Connect source, if we're making any async HTML or rather HTTP XML style requests. If we've got fonts, everyone knows fonts, images, medias, object, if you really want to embed Flash in your page, scripts and styles. Now here's the really important bit here. What this part of the content security policy is doing is saying that you can load any of these things from self. You can also load any of these things from New Relic, which is analytics or rather orchestration of how long pages and things take to load, and also from Google. And Google is used on my site for things like reCAPTCHA and also Google Analytics. The point is that this first part of the policy is saying that anything can be loaded, so anything like fonts, images, etc., can be loaded from myself, so from my own site or from those two other sites. And that's kind of our generic catch-all. Now these two I'm going to come back to because there's something a little bit special about these guys. Now we then move on and we talk about very specific content types. So scripts. Scripts we can load from ourself, and we can also load, I'm going to skip these two and come back to them. We can also load from Google, Google Static, APIs, Google Analytics, and so on and so forth. And I've got a whole bunch of different values just here in terms of trusted sites. So another one, for example, cdnjs.cloudflare.com. I load a jQuery from Cloudflare's CDN. The point is that what's happening here is that this is very explicitly telling the browser where it can load scripts from. We have to repeat self, even though we've got self up here as a default source. We have to repeat self because once we actually declare a content type, then it overrides everything that was a little bit higher up. Now, how does this help actually protect against the risk of XSS? So if we go back to those Dutch banks, what benefit would this give the bank other than people like me not being able to play the Harlem Shake in people's browser? Well, cross-site scripting attacks will often try and load external content into the browser. So one of the first things you often see people trying to do is run arbitrary JavaScript. Now, what this is saying is that even if you can modify the source code of the page, you cannot insert a script tag which then pulls a JavaScript file off another server which is not listed here, or off another host name that is not listed here. Now, if you manage to upload your own arbitrary JavaScript onto google.com, good luck with that as well, by the way, uploading it onto www.google.com. Different story if there are other domains that Google has that does allow you to load arbitrary content into, but you shouldn't be able to get it into google.com. So what the policy here is doing is saying that you cannot load a script from anywhere other than one of these domains that you're seeing here. And then we go on. Object sources. You get no objects on my site. I do not have any Java sort of applets that embed in the page. I do not have any Flash. I do not have any Silverlight or anything else that requires an object tag. So you can't even load that from my own site. If I tried to put a Flash movie on my site, this content security policy would stop it from running. Styles we can get from ourselves. We'll come back to that one. And we can get from the Cloudflare CDN because I use Bootstrap, which I serve off their service rather than serving it off my site where I have to pay for it. That is, I have to pay for the bandwidth anyway. Images, getting pretty self-explanatory here. We all know what that is. Media, there is no media on my site, so I'm blocking it. Fonts, we also get that off Cloudflare because I'm using Font Awesome. Connect sources, if we're making any XML HTTP requests, I think I might have mispronounced that earlier on, but if we are making any of these nice sort of modern day asyncy sort of requests, we can get that off this Visual Studio address because I was using their analytics service in order to do stuff effectively like New Relic, but different service, different host name. Child sources, so this is when you put a frame on your page. I've got this New Relic one here because I embed New Relic performance stats in an iframe on one of my pages. Frame ancestors. Now this is quite different because what the frame ancestor is saying is that my site may not appear in the frame of another site. Now this is often used to prevent against a risk like clickjacking. So you can't create a site and then put my frame inside it and trick people into clicking links on my site whilst they might be authenticated to my site by using a clickjacking style technique. If you're not familiar with clickjacking, give it a quick Google. So all of these things are being very explicit about what my site can do, and particularly where my site can load content from. The very last thing you'll see here is a report URI, which incidentally is the same as the name of this website, just coincidentally because Scott has actually named his service after the fact that when you have a CSP, you have the ability to report. And you'll see my report URI is set to this value. So it's calling a subdomain of have I been pwned on .report-uri.io, blah, 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 blah. Don't worry too much about the path. Let me show you what that does. If I jump back to have I been pwned, and incidentally, you'll notice that report URI down here. So again, what we just saw on the other tab is just a nice visual representation of this great big kludge of CSP response header. If I now go and let's say jump back to the console, we'll paste in that whole Harlem Shake again, which won't work. Back to the network tab, all the way down to the bottom. And we've got these two requests, these two enforce requests. And here's what you'll see. Let's look at the first one. That has made a request to that address. So that address is the one that's down here, the report URI. What this is is this is a feature of CSP, which means that if a violation occurs in the browser can report that violation back to an address of your choosing. Let's have a look at what's in the report. It is a post request. It has a body to it. So we can go down and look at our request payload. And here is our CSP report. So have a look at what it's saying here. It's blocked this URI. All right, so it blocked the browser trying to load something from Amazon. The document URI that the policy was violated on is this URI. So that's the address up here in the address bar. It violated the style source directive. So this was when we were trying to embed a style sheet in the page. And then you get the full original policy and you get the violated policy, which was this style source policy. So we can then sort of scroll across and we can see all the directives and things that were listed in that style source. So that's the reporting, and the reporting is neat because what it means is that when things go wrong on your site or when things happen in an unexpected way, you can get the report. And by setting my report so that it sends it over to here, Scott's site, which is at report-uri.io, he actually aggregates all the reports. And then you can go up and jump into the nav and he's got all these funky graphs and things, and you can see what is the stuff that's breaking on my site in someone's browser. Now that may mean that you have an XSS risk and someone's actually embedding arbitrary script. It may mean that you've got a browser plugin modifying your DOM, trying to upload, or rather trying to pull in external content from other sources. Now that's kind of interesting. So I see, for example, violation reports from, say, the Evernote Clipper in Safari, because this Evernote add-on is trying to modify the page in someone's browser, and then it's causing this exception to be raised. So all of that's interesting. Couple of other things while we're here, because I skipped over them. So one of them is, I skipped over this. So let's talk about this. Unsafe Inline, and I've got a little red flag against it. If I go back over to Have I Been Pwned, and we'll look at that original response header, we will see I have got in my script source directive this unsafe inline keyword. Now, unsafe inline script is essentially just a block of JavaScript in the source code. And we've probably all done this before if you're building web pages. You open up a script tag, you put your JavaScript directly in the source. Attackers love to do this. They love to do this to mount XSS attacks. And in fact, every time I do a workshop and we have an exercise where people need to mount an XSS attack, they need to put script on the page, the first thing they try to do in, say, a search function or something is they say script, and then they start writing JavaScript. And if that gets reflected into the page, so say if it's in a search box and you hit submit, and then the search page that shows the results reflects that term, if that script gets written into the page, then you get to run JavaScript in someone's browser. Now this is unsafe, and it's unsafe because of what you can do with it. So by default, the content security policy will not allow you to have a script tag in your source. Now, not only does that mean that an attacker can't run a script tag in your source, they can put it in there, but the browser won't run it because it looks at the policy. It also means that you can't put one in. So if you've got a script tag in the source code of your page, then it's not going to run. The browser will block it as soon as you implement the CSP. What I've done is I've turned that feature off. So by adding this unsafe inline keyword here, my browser is saying, okay, I will run script that is in the source code of your page. Now let's have a look at why I have script in the source code of my page. It's this guy just here. Everyone is probably pretty familiar with this. There's a little bit of a giveaway here. The reason why I'm doing this is because I wanted to implement a CSP on Have I Been Pwned and not change the code of the site. And I do this in order to then go and talk to people, go into these organizations, do these workshops, and say, you can implement a CSP without changing your code. Now, by allowing unsafe inline script, we've effectively got the same risk profile as before when we had no CSP whatsoever as it relates to running script in the source page. I still get all the protections of not being able to do Harlem Shake or load external images, but this is basically the default position with no CSP. Now, how would I fix this? What is the right way to fix this? Well, the right way would be to take this script and pull it out, put it in an external file, and then embed that just as a JavaScript, or rather as a script tag, and then have a source attribute which pulls it in from a, say, a .js file. If I did that, that would move this out of the page, and then I could remove that unsafe inline directive. But there's a couple of other things we could do as well. So one of the other things I could do is that if I didn't have that unsafe inline tag, or that unsafe inline, what's the right word? Keyword in my directives, then what would happen is Chrome would actually throw an error when it saw this script tag. So what it would do is it would throw an error which would appear in the console just like these guys have. And in that error, it would have a hash. And that hash is a hash of everything there in the script tag. I can whitelist that hash as another script source, just in here with all the other ones. So think about what this means. I can say that this is known good JavaScript. It is always allowed to run, and it's returned in the response header. And that means that the browser will then trust it. XSS attacks don't modify response headers, they modify response bodies. So it's not like an attacker can go, I'm just going to drop arbitrary script in the page, and I'm also going to add a CSP response header, which then allows unsafe inline. That won't work. So we've got to think about where attackers have access to modify things and where they don't. So that's one thing I could do. I could add the hash of this, and then make sure that I return that hash as a source. The other thing you can do with CSPs is you can use a nonce. And the way the nonce works is I can have an attribute on my script tag that returns a nonce, and I can also return that nonce in a response header. Now, just in case that term is unfamiliar, a nonce is a number used once. If I reload the page, I get a different nonce. And what it's doing here is saying this is a way where I can say, I'm going to whack a script tag on the page, and even though I have a CSP that normally won't allow script tags to run, it's always going to allow any of the script in a tag with that nonce to execute. Now that's a bit risky too, because what if you are reflecting untrusted user data into the source code of the page, and it's within a script tag that has a nonce? That would be a problem, but again, it's kind of the problem that we already have when we're not using CSP in the first place. However, in a case like this, with just Google Analytics, and apparently Google Analytics say, look, you really should have a script tag in your head, so let's humor them and say, okay, that's what you should do. If we actually had that nonce here, it wouldn't really pose a risk, because in my source code, this is a static piece of content anyway, this whole thing here. There's no untrusted user data being reflected into the page or being loaded from persistent storage or anything like that. So this would actually be an acceptable risk in my books. I've gone on a little bit there, but that's the point. Multiple different ways of handling script on the page, so you can kind of turn the dial around to whatever your comfort level is. Going back to here, we also had unsafe eval. So if you're familiar with the eval statement in JavaScript, eval allows you to build up a string and then execute it, which is really, really useful for not SQL injection attacks, for cross-site scripting attacks, because an attacker can then use that to do things like circumvent validation of untrusted data, so circumvent any sanitization. I'm not going to pass a keyword which this site would otherwise block. I'm going to pass half a keyword and then add it to another half a keyword, and then by breaking that string in half, concatenating them together, and then evaling them, it's going to execute the payload. So eval can be dangerous. It gets disabled by default. I have re-enabled it because one of the external libraries I use uses the eval keyword. Now again, I could find other ways of doing this, but the point I wanted to make here is that I have implemented the entire CSP with no code changes to the site. And I'm going to show you how I do that in ASP.NET in a moment as well. So that's those two guys. One other one we saw. Unsafe inline for style. So you've probably seen an HTML tag with a style attribute, and inside that style attribute you've got something like, let's set the padding on this element or the font size or some other arbitrary little setting. Now, the problem is the same one with untrusted scripts or unsafe scripts, in that if an attacker is able to reflect CSS to the page, so via reflected XSS, or they're able to get it into the page via persistent XSS, they could modify the page. So they could put a block of text on the page, add a style attribute, and then start to change the behavior of that page. So that gets blocked as well. And like the Unsafe Inline script, I already had elements on my page setting styles, and I wanted to put my CSP on the site without breaking anything and without actually changing any code. So this is what I've done. And again, this really just puts us back in the same position as having no CSP whatsoever as it relates to the security of unsafe inline styles. Now, with both this and the JavaScript, even from just a good web design practice, what we should be doing is taking these values, so taking the value of our whatever our script tag is, and then taking the value of those little style attributes and putting them in external files. So this should go into a CSS file with a class, and then we drop the class on the element. It's just good design practice. There are certain cases where you actually want to have unsafe inline styles and scripts. So for example, sometimes you want it for performance reasons. I've just done this on my new blog because it actually saves me making an additional request, or saves you making an additional request by not putting it in an external JavaScript file, and it's a really, really tiny bit of JS anyway. So there are ways of handling all of these things by deciding how strict you want to be with the CSP. Now, one other thing before we move on. If you want to implement a CSP, but you're scared, and you should be a little bit scared because CSPs can break stuff, you can implement a content-security-policy-report-only response header. And when you add -report-only, it does just what it sounds like it will do. It will only report. It will not block. So what this means is that you can try and get your CSP spot on, absolutely perfect. And you can roll it out into your production system. You've tested it like crazy. And then you can just watch the reports. And you might find there are reports that show that there's this edge case that you've missed somewhere. But because you've got the report-only directive on the end of this, or rather report-only words on the end of this response header name, it won't block the content from the user. So nothing will break for the user, but you'll get the reports. So you can do content-security-policy-report-only, get all of these reports, and then when you're super, super happy that everything is solid, then you just take out that -report-only and you're good to go. So that's that. That's how that works. Now, often what I'll do in workshops is I get people to build their own content security policy. And I get them to do it for their own company site because 99-point-something% of sites do not have a CSP. It's really rare at the moment. And I get them to do that and they go through some degree of pain, and it's like, it is hard building a CSP. And then I show them the easy way. And the easy way is, if we jump over to Fiddler, there is a way that we can do this just by looking, or rather just by using a little add-on. So here's what I'm going to do. I did a little bit of testing earlier. I'm going to clear all those results. Jump back to the browser. We'll grab a new tab. We'll go back to Bank of America again, which we know doesn't have a CSP because we can make it dance. And we'll load this site. Now, what we're going to do, actually, I'll tell you what we're going to do. We're going to turn it on first. We're going to go back to Fiddler, go to the Csp Rule Collector add-on. I think it was actually turned on. And no, actually, it wasn't turned on. Let's do this. Enable rule collection, clear results, back to there, reload the page. The Csp Rule Collector add-on is a free add-on. You can go and grab that, and then you'll see all of our requests coming in here. We can click on a request, we can click on the URI, and down here is the CSP which you need for that page. It's neat, right? Like all you do is just load the page. And we can see here a very familiar sort of set of terminology, connect sources that are allowed. We've got font sources here. Font sources can load from self. It looks like they've got a frame source, which is over here. All right, so we can see different directives being represented here. and the whole thing being constructed based on what's actually being used by the site. It's broken out a little bit more neatly down here as well. So this makes it kind of cool, because what you can do now is you can just go and grab this and add that to your response header. Except it's not quite that simple, because part of the problem is that different pages on that same site may load different content from different sources. So you might go to the home page and you have a CSP that looks like this, and then you go to the About page and it embeds an image from a different CDN. So that's actually going to need to add one more attribute to the image source directive. So you got to kind of browse through the site a bit and make sure all the content from all the different places gets loaded. Then you've got to remember that different browsers may load different content from different places. So we've done this in Chrome, that's cool. What if I did it now in Firefox and Firefox decided to use a different video type and grab it from a different host name? So be a bit conscious about that as well. But once you do this and you go through and you collect your CSP, now you can talk about getting that into your web app. Now, it is just a response header. If you have a header that's named content-security-policy, and then you have a value which looks like this one here, then magic happens and the CSP works. But there's an easier way of doing that if you're in ASP.NET World. And the way is, in fact, you know what I'll do? I'll go back to my browser. I'll show you. If we go to NuGet, which is our package management system for ASP.NET. If you don't work in ASP.NET, you may find a similar package for your framework of choice. And we go to nwebsec, which is made by fellow developer security MVP, Andre Klingsheim. You can go and get this package. And nwebsec makes it really, really simple to add a content security policy to your ASP.NET website. So what you do is you pull in the package, and then we jump back to my notepad and we do something like this. So this is my web.config for have I been pwned. Here is where nwebsec goes in. Here is where the content security policy goes in. And what you're now seeing is a nice sort of configuration-centric means of representing the policy. So here's our default source. We trust self for default source. Here's our script source. We allow unsafe inline, we allow unsafe eval, we allow self, and then we allow all these other sources. So see how neat that is to configure? And then as we scroll down, we see all the other values. Even all the way down to things like the report URI, which I had configured. Further down, you'll also see we can do things like public key pins, which I won't go into here, but that's another thing. nwebsec helps you configure that. So it makes that really, really easy. A couple of other things whilst we're looking here at nwebsec and whilst we're looking at my web.config. You'll notice I've got a comment here. Safari needs frame source, so these are here to cater for it. We do have a bit of a parity problem with browsers, and I'm going to show you browser compatibility in just a moment too. And the parity problem is Safari is a bit, it's a nice way of putting this, a bit neurotic in that it doesn't recognize the agreed spec for how we refer to a frame on a page. So the ratified approach, if you like, is that you should have a child source directive. And the child source, for example, says that I may embed things from rpm.newrelic.com into my page. However, Safari does not know what a child source is. Safari would actually like to use a frame source, which is wrong. Now, this is problematic because when I put my CSP out there, I opened it up on my iPhone, so I opened up the page that embedded the New Relic report in a frame on my iPhone with Safari, and I couldn't see the report. So Safari actually blocked it. Now, this is a bit of a drama, and I didn't want to go and add a frame-source directive here because that's kind of wrong. And I also, in fact, I think from memory, off the top of my head, nwebsec doesn't have a configuration for frame-source because it's wrong. But the way I've gotten around this is I've added these two resources as a default source. Now, unfortunately, what that means is that I can also load anything from rpmnewrelic.com or from google.com that is not already listed here. So if there's another directive or another content type that I haven't already listed here, then I would be able to load that particular content type from New Relic or from Google. And let me just clarify that again. Remember I said earlier, you've got to then go through and whitelist everything again. So even though I've said default source self equals true, as in I can load anything, as soon as I say script source, it overrides this for anything of a script type. That's why we've had to do self true again, and then we've added all these other things. So what that means is that you could not load script from this host name, right? There's another New Relic address down here, but you couldn't load script from this one. So that's why I've got this in here. And I wanted to sort of tell that story because it just points out the fact that you can really break stuff using your content security policy. Now, one more thing before I talk about compatibility. Down here, where we have this report URI, NWebSec also has a neat little configuration where your report URI can be a handler on your own website, and then there's an event you can catch which has the whole report. You're going to need to write code here. You're going to need to listen to that event, catch it, and then you can grab that report and do something like dump it into table storage in Azure, which is what I used to do. But I kind of like the idea of using a service like this one. And even though I'm sending data off to Scott's site, and as nice a guy as Scott is, and I would, if I were you, I would question whether you want to send data to another party, think about what the data is. There's no PII, there's nothing of a sensitive nature. It is, here is a policy which has been violated, and this is why it was violated. So we saw that before in the browser when we looked at the actual payload. So last thing, almost last thing. If we go to caniuse.com, which if it is unfamiliar to you, I really recommend using caniuse.com because it tells you if you can use all sorts of webby things with different browsers. And we look at CSP, what you'll see here, we'll start with the good news. What you'll see here is that 80% of people browsing the web around the world can use Content Security Policy 1.0. The main standout here in terms of the popular browsers, which is not supporting CSP 1.0, is the guy in this column. And we'll actually say there's a little keynote over here. It is supported through the x-content-security-policy header, which really sucks because the x- means it's a non-standard header, number one. And number two, I don't want to add the same content security policy twice, and I have all that kludge in the response header, and then all I've done is just added an x- to one of them. So that's a little bit of a pain, but look, then again, you see the browser usage there, it's 5.4% globally. And here's the other thing I ask people. If you have a browser that gets a content security response header and it doesn't understand it, so say IE11 gets one without the X prefix, what does it do? It's got this header. What do I do with the header? Well, it doesn't do anything. It just kind of goes, I don't know, it goes about its business and processes the rest of the page. So you don't lose anything by sending a CSP header to a browser that doesn't understand it. Now let's scroll down a bit because this is where it gets a bit more interesting. Content Security Policy Level 2. Now we're at only just over half of the global audience. And I probably don't need to point out which columns a little bit further down are all red. And it's a real shame because these guys are just simply not supporting CSP. Now, on one hand, it's a shame because we'd obviously like IE and Edge to support content security policies. On the other hand, Edge, 1% of traffic. IE11 we saw before, 5.4. That is a very small amount. And again, if they get that header, they just don't do anything. It's like they go about their business and they kind of move on. There are some idiosyncrasies with Firefox as well. A few little things. So Firefox 36 Plus is missing plugin types and child source directives. But the reality of it is that a huge bulk of the audience, so 52.3%, gets some degree of CSP protection. And some degree is better than no degree, which is what we have when we have no CSP whatsoever. Now, the last thing I'll add to this video, and I'll put another few notes on the blog, which I will put this video in, is that this is not an excuse to have cross-site scripting vulnerabilities on your website. And I've seen people before say, well, the CSP is kind of pointless. You just don't have XSS risks and everything is okay. And I really like the idea of not having XSS risks. But I also know that despite the best of intentions, these things sometimes still happen. You have one person who misses one little thing and now you've got a cross-site scripting problem. We see some interesting edge cases. We see scenarios where apps are doing things like connecting to external services and they trust the response of the external service and then the external service has XSS. We've seen things like Whois services loading DNS records and there are TXT entries on DNS records with XSS in them. It's a real thing. So this happens and we need to think of the CSP as another layer of defense on top of sanitizing inputs, properly outcoding responses, and doing all the other things that we should be doing to prevent against the risk of XSS. Finally, my suggestion is implement the CSP in a very low friction way. So implement it such that you allow everything you think needs to be allowed, you test it carefully, you implement it as report only, you catch the reports using Scott's service or send it to your own site, you see how it's going, and then when you're comfortable it's safe and you've got it all right, then you take out that report only and you lock it down. And you can do this incrementally. You can do what I've done and allow unsafe inline script and then allow unsafe eval and not make any code changes. And then over time, you can start to sort of refine that a little bit, perhaps add some nonces to some of those scripts or some hashes, perhaps take those script tags out altogether and gradually increase the security of the site. This is a really neat little tool, and it's something which is evolving. We'll see new generations of CSP yet to come. But I reckon it's a good addition to all the other good security defenses that you should have. And even though you may not care too much about people playing the Harlem Shake on your page, it does actually do other really, really useful things with XSS with it, which is actually a pretty serious risk. So give CSPs a go. I'm going to add more notes and links to courses and things like that on the blog itself. I reckon it's a good thing. Give it a go.